Okay, so I've recently made a pretty big change to the Rise framework. I used to have an entity system which was a little naive, a little simplistic. I started to encounter some issues with it, so I decided to start researching the entity component system or entity component architecture. I found a really good article on gameprogrammingpatterns.com by Robert Nystrom. And it covers the pattern quite well. It talks about some of the benefits that you can get from it. So I researched into this quite heavily and then started to refactor out my code to include a more component-based architecture. And what I ended up with was I essentially created an entity base class, which includes a list of components. You can find components, add your components. Each entity has this send method, which allows messages to be passed back and forth between components. So that's one thing Bob talks about here. He talks about communication somewhere. I think it's towards the bottom. There you go. How do components communicate with each other? So he talks about here about events and messaging. I ended up choosing the message approach. I haven't actually used this in Anger yet, so I don't know if it's going to work quite like this. You'll notice that it also contains a transform component. Another piece of advice a lot of people give is that transform is such a common piece of data that most entities have, that it's worth putting it on the entity itself rather than inside the list. That way each component can have access to this transform information. So just to give you an idea, the transform component at the moment just has a position vector in my case, but you could add things like scale and rotation if you supported that. You'll notice here that this is the other end of the message pattern. So once the entity receives a message, it loops through the components and then passes the message down through this receive method, and that's kind of how that works. So let's go into component to see how that works. I do have an isActive flag. I haven't started using this yet. The idea is that if a component is not active, it won't receive any update calls or messages. So this is actually slightly out of date at the moment, because originally my original design, each component had update methods. So that meant that the components themselves were responsible for performing any logic that needed to be performed on their data. So, for example, a renderable component would have an update call, which would in turn do all the rendering, which a number of people talk about as maybe not the best way to go. I mean, that's a very object-orientated way to go, to have your data and your logic contained in the same class, but often with component systems, it's a good idea to separate the two out, and I'll show you how I did that in a moment. So this is the base class for all components. Obviously it has the abstract receive method that they all have to implement. They all have a type, which I've kind of exposed here. The reason I've done this is kind of what I would refer to as poor man's reflection. So I don't have to test the type of each component as I'm looping through them. I can look at this type property and compare it against one of these values to know what type it is. And you can kind of see here, you get a nice enumerated list of all the component types I have at the moment. Some of these may come out like movement. I think I'm going to be removing. Each component has an owner, which is the entity which owns it. The protected constructor here accepts that in and sets it. This allows each component to, for example, call the send method, which in turn calls the receive, so they can broadcast messages, but also it allows access to that transform component I mentioned earlier. So that's one of the benefits of owning your owner reference. So if I come back out and go into some other components, show you what else I've got here. So I've got a renderable component, and this has it's just a method which returns an atlas image, and it's virtual again, pure virtual. So in this case I have a sprite component which contains a sprite, and the get image method in this case just returns the sprite's get current image. So if this sprite was animated, for example, the renderable component would simply just return the current image for that sprite's animation. So you can have different types of renderable components. So for example, you might have a solid rectangle color which is of type renderable component but isn't necessarily a sprite, so that'll enable you to do kind of debug sprites and things like that. So that's the reason I separated those out. There's also a physics component. This contains the obvious things like velocity. At the moment it contains position, but because I've created that transform component on the entity, I'm thinking of refactoring this away. It also has desired position, which is currently just how my collision code currently works. Again, I'm going to hopefully be refactoring this away, so ultimately this component will just boil down to velocity and some constant data here around the time steps for physics updates, that kind of thing. So I can you can kind of see how some of that works here with the accumulator for getting the fixed time step code working. There's also the collision component. Again, this carries a position. I'll be removing that. Some of the methods here probably are going to be removed. I've added these to kind of solve some issues. When I added this approach, I needed to kind of make some parts of the code work, so I've added some of this stuff. This is probably going to get removed. But the main important thing here is the bounds. So this component carries the bounds of the entity, so it's the collision rectangle that defines the bounds of the object. We've then got a controller component. Now this ultimately you can see the update method there, that's from the old approach I took. This ultimately will be the component which drives the movement of an entity. So in the case of a player, that would be a keyboard component or a mouse component or an input component, maybe to control both. It could be if it was an enemy, it could be, for example, an AI component. So you can think of this like the driver, the code which drives the entity. So if it was an AI component, it would be AI algorithms which would produce the desired behavior for the component, whereas in the case of a player it would be input from the input devices. And again, you could swap. The good thing about the component design is you can swap these components in and out. So you could, for example, have a player component that's controlled by AI in certain scenarios, like for example maybe a demo recording at the start of the game, and then when the player takes control, that component gets swapped out for the input component, so it provides flexibility there. So that's kind of a breakdown of how all the entities and the components work. But one thing I struggled with was kind of how to define the systems which control these components and the systems which update them. And like I mentioned, I originally started with this update method, which was a kind of traditional OOP approach where the data contained within the classes were controlled by the class itself via the update method. But then I moved out into another common approach, which is to have systems which are fed the components. So in the case of the rendering controller, the reason I called them controllers is because this kind of made sense to me as an MVC kind of pattern, where the components are the models and these classes become the controllers to drive those components. So you can see the rendering controller has a draw method, and it accepts a list of renderable component pointers. So this is an array of renderable components, which ultimately the renderer will loop over, call the underlying OpenGL begin and end frame methods, and call my draw texture atlas image method, which accepts the virtual get image data and passes in the positional data from the transform. You can see here this is where this component is going back up to its owner, then going back down to the transform component, and then getting the position data out to position the image at the appropriate place. A lot of this is going to get refactored again to kind of take advantage of optimization things I can do here to improve this. This is again quite a naive approach. It was simply just done to get the principles in place, and then I'll come back to optimizing it. You can also see the physics controller here. So this is where we have the advanced method, which advances the physics simulation. So for example, it actually starts with the update method, and this is where the accumulator comes in. So it will check to make sure we've accumulated enough to advance the simulation. It then loops over the components and passes each one into the advance method, and that then does the physics calculations to include gravity and update the velocity, apply friction, and all that kind of thing. It has a reference to the collision controller, which in turn resolves the collisions using a sweep method. So it starts off with a broad phase rectangle, and then goes on to do a more fine part of the collision code. This part of the code I'm still kind of working on to get it working in the component fashion, because it returns certain things that aren't currently being used, so I need to kind of work on that part of it. The part of the code that I'm actually struggling with at the moment is the state controller. I'm currently trying to model the components using to model the states using a state component. I don't know if this is the right way to go at the moment. I've got these states here for walking left, walking right, a flag to say they're on the ground. I don't know if this is the right way to go. I'm going to keep working at it and see if I can kind of resolve some of the issues, but that gives you an idea of how I've approached the component architecture. Hopefully it will save some of you guys some time, because I know that I tried to look for some information on this and it was actually quite hard to find, so hopefully this will give you some insights. Okay, cheers.